So welcome one and all. In continuation to the previous lectures on the exact differential equations, so today we will see one more type of integrating factor. So in the previous sessions we have discussed how to find out an integrating factor, or otherwise the integrating factor is of the form 1 by mx plus ny and another one is 1 by mx minus ny. So these two cases we have discussed how to identify the integrating factor as 1 by mx plus ny. So we have, if the d is exact, d is not an exact d and d is homogeneous, then we can take the integrating factor as 1 by mx plus ny. And second one, if the given d is not an exact de and we have certain standard form for the equation, then we can take the integrating factor as 1 by mx minus ny. Now we are coming to the another case. So this case is comes under when the integrating factor is a function of y alone. So means here how can we identify that? So as usually, whenever the given d is of the form m dx plus n dy is equal to 0, so in generally what we will do, we will check for the exactness. So means now we will calculate dou m by dou y and we will calculate dou n by dou x and we will check it whether it is exact or not. Okay, so suppose if it is not exact, means dou m by dou y is not equal to dou n by dou x, and this differential equation m dx plus n dy does not comes under these two cases, means this equation is not a homogeneous differential equation and this equation is not in that standard form. Case 2 that what we have discussed is y into f of xy dx plus x into g of xy dy is equal to 0. Once again I repeat, this differential equation m dx plus n dy is equal to 0 is not an exact de, that is the first point. Second point, it is not homogeneous and it is not in this form y into f of xy something. The d fails to be these three cases, fails to follow these three: not exact, not homogeneous, not in this form. Then we need to check it 1 by m into dou n by dou x minus dou m by dou y. We need to check this value 1 by m into dou n by dou x minus dou m by dou y. We need to check this value. If this one is, or if the value is a function of y alone, say some f of y, it must be a function of y alone. So if it is a function of y alone, then the integrating factor is given as e power integral f of y dy. Okay, so in the case 1, for a non-exact differential equation, if the d is homogeneous, then the integrating factor is 1 by mx plus ny. If the d is in this form y into f of xy dx plus x into g of xy dy, then the integrating factor is 1 by mx plus ny. If those two are not the cases here for the given de, then we need to check this value 1 by m into dou n by dou x minus dou m by dou y. If it is a function of y alone, some f of y, then the integrating factor is of the form e power integral f of y dy. So this is how we can identify this integrating factor. Now we will see this with the help of one example. Now if problem is given something like this, so y plus xy square dx minus x dy is equal to 0. Now as usually you take this one as some equation 1. Now first of all we will check whether it is exact or not. Okay. To verify the exactness of equation 1. So now clearly equation 1 is of the form m dx plus n dy is equal to 0. So this is all m and this minus x is nothing but n. Okay, so now otherwise if you want you can write. So equation 1 is of the form, because in the examinations we cannot write like this, so now we can write it. Equation 1 is of the form, simply I am writing here m dx plus n dy is equal to 0, where m is equal to, means a function of xy, m is a function of xy, m is equal to some y plus xy square, and n is equal to, so here we have only minus x. Now you calculate the partial derivatives. Now dou m by dou y is equal to, so derivative of y is 1 and here x is a constant and derivative of y square is 2y, so means you will get 1 plus 2xy. Okay, so if you want you can take it as some equation A and you calculate, similarly calculate the partial derivative of n with respect to x. So derivative of x is 1, so means we will get dou n by dou x is some minus 1. Take this one as some equation B. So from these two equations what we can conclude? Therefore from the equations A and B we get that dou m by dou y is not equal to dou n by dou x. So therefore we can conclude that equation 1 is not exact. Okay, now the question is which integrating factor we have to apply. Now you check whether this is a given d is a homogeneous d. So given d is not a homogeneous d, means 1 by mx plus ny is not an integrating factor. Now you check the second case, whether we have product terms here. If you take y as common in m, so then there will be there is a one product term here, but here if you take x as common, then there are no product terms. So therefore 1 by mx plus ny is also not an integrating factor. So therefore now we will check this function, it is 1 by m into dou n by dou x minus dou m by dou y. Now we will check this value. Okay, so because the first two cases fails here, therefore now we will check it. So that is nothing but dou n by dou x. What is dou n by dou x? Here we have from equation B we have minus 1 minus dou m by dou y. Dou m by dou y. So from equation A here we have, what is that? 1 plus 2xy divided by m. What is m here? Y plus xy square here we have. Now you just simplify this, so minus 1. So here we have minus 1 minus 1 minus 2 minus 2 minus, here we have negative sign, minus 2xy divided by, here we have, better you can take y as common here, 1 plus xy square we will get it. In the numerator also you take minus 2 as common, minus 2 into 1 plus so after taking y as common, he will get 1 plus xy only. Okay, 1 plus xy divided by y into 1 plus xy. Okay, so this 1 plus xy and 1 plus xy cancels out and we will get it as minus 2 by y. So if you observe, we got it as a function of y alone. So now you can call it as some f of y. So therefore it is 100% clear that the integrating factor of equation 1 is nothing but if is equal to e power integral f of y dy, because here if you got it as this value 1 by n into dou n by dou x minus dou m by dou y is a function of y alone, so then there is no doubt that the integrating factor is e power integral f of y. So this is equal to e power integral of, what is f of y? Here we got it as f of y value is minus 2 by y dy. So this is equal to e power minus 2 into integral of 1 by y is nothing but log y. So now we can write it as e power log of 1 by y square we can write. So e power log of 1 by y square means we get it as 1 by y square. Okay, so therefore now the integrating factor is 1 by y square. Now we have to multiply the given dE with this integrating factor, and then the given dE reduces as a exact differential equation, and then we can find out the solution. Okay, now we will multiply the given dE with this integrating factor 1 by y square. Okay, now we will see 1 by y square into, otherwise you write by multiplying equation 1 with the integrating factor 1 by y square, we get 1 by y square into, so I would like to write the given dE first of all. So y plus xy square minus x dy, y plus xy square minus x dy is equal to 0. Now you simplify this, then we will get y by y square means 1 by y plus y square by y square means x only, is because y square and y square cancel out, minus x by y square into dy is equal to 0. This is nothing but equation 2. So here also no need to verify whether equation 2 is exact or not, otherwise simply here I will show you. Now if you assume this one as m1 and this one as n1, so what is dou m1 by dou y? Just for the information, so dou m1 by dou y means derivative of 1 by y, that is minus 1 by y square, and derivative of x is 0, and similarly dou n1 by dou x, if we check it, dou n1 by dou x is equal, derivative of x is 1 minus 1 by y square. So if we observe, dou n1 by dou y is nothing but same as dou n1 by dou x, means equation 2 is exact. So you can write clearly equation 2 is exact. So therefore the general solution of equation 2 is given by, so we know the formula, integral over treating y as a constant m1 dx plus integral over the terms in n1 which are free from x into dy is equal to c, where c is an arbitrary constant. Now by using this formula we can find out the general solution. So now you substitute all the values in the sense you substitute what is m1 and what are the terms we have to take from n1. So m1 here we have 1 by y plus x, so this is 1 by y plus x into dx plus integral over, so in n1 we have to take the terms which are free from x, so there are no terms here, only one term we have, in that one also we have x, so therefore we will get only 0 into dy is equal to c, where c is an arbitrary constant. So this implies, now we'll calculate here 1 by y is a constant, so means 1 by y into x we will get, plus integral of x means we get x square by 2 is equal to c, already here we have. So means now if we simplify this, then we can write it as, by taking 2y as LCM, we can write it as 2x plus x square y is equal to 2cy, or otherwise the 2c we can take it as some c1, then we can write it as 2x plus x square y is equal to c1y, where of course c1 is nothing but 2c. And finally here we can conclude that which is the general solution of equation 1, or otherwise the given differential equation. So this is how, by multiplying the given differential equation with the integrating factor, we can convert that one into exact and we can find the general solution. Let me conclude once again. So whenever a dE is given which is in the form of mdx plus ndy is equal to 0, and it is identified that it is not an exact dE and it doesn't comes under case 1 and case 2, in the sense it is not homogeneous, means 1 by mx plus ny is not an integrating factor. Similarly 1 by mx minus ny is not an integrating factor, because this is not in the standard form of some y into f of xy dx plus x into g of xy dy is equal to 0. So therefore we will try to identify this function. So 1 by m into dou n by dou x minus dou m by dou y, and here we got it as a function of y alone. Then undoubtedly, as per the theory, so this integrating factor is given as e power integral f of y dy, and by simplifying here it is, we got it as 1 by y square. Now just you multiply the given dE with that integrating factor 1 by y square, then automatically the given dE transforms to an exact differential equation, and then we know how to find out the solution by using this formula, which gives us given by the general solution. Okay, by the help of that we will got it, the general solution for the given differential equation. So this is how we can convert a non-exact dE as an exact dE by using this case. Thank you one and all.